So we just finished up with minerals, now we can talk about rocks. So let's move into chapter 5.1 and talk about igneous rocks. So by the end of this section, you should be able to explain how an igneous rock forms. You should know the three different types of magma. You should be able to describe what silica is and also what silica influences, as well as explain the terms partial melting, fractional crystallization, and Bowen's reaction series. So first, let's establish that an igneous rock forms when magma or lava cools and then crystallizes. So remember, we talked about with minerals, as this magma is cooling, these crystals are going to start to develop. The longer you give it, the bigger those crystals will be. So the difference between magma and lava. Magma is the molten material below Earth's surface, whereas lava is that same molten material just on Earth's surface. So it's literally the same thing, just named for where you find it. Magma is below ground, and lava is above ground. So this magma, this lava, is made of molten rock, dissolved gases, and minerals. So this magma forms from essentially Earth's crust and rock melting. And this happens within Earth's crust and within the mantle. However, temperature, pressure, water content, and then even the mineral content influence when and how this melts. So typically these rocks melt between 800 and 1200 degrees Celsius, and this happens in the upper mantle. But again, it does vary depending on these conditions. So one thing to establish, as you go deeper into the Earth, your temperature is going to increase, and that's known as the geothermal gradient. So I know it sounds like a big word, but geo means Earth, thermal means heat, so it's essentially Earth's heat gradient. So it's looking at how the temperature changes as you go deeper into the Earth. And then also pressure, and the pressure increases as well due to the weight of the rocks above it. So if you think about it, you swim down to the bottom of your pool, you feel that pressure even just 10 feet down because you can feel it pushing in on your ears. You could also think about in football, if there's a guy at the bottom of a dog pile, he's going to feel the weight of all the people above him, whereas the person on top is not going to really feel any of that pressure. So pressure increases as you go down and as more stuff piles up on top of you. So this melting point of this rock and crust, it increases with pressure. So that means that it takes a higher temperature to melt the rock when it's under more pressure. And at the same time, if there's more water within the rock, then it's also going to melt quicker. So then we can think about the composition of magma. So essentially the elements in this melting rock are going to determine the composition of the magma. So a lot of these common elements that you'll see in Earth's crust are oxygen, silicon, aluminum, iron, magnesium, and so on. Remember, with oxygen and silicon, we talked about this back in minerals. Oxygen and silicon together form silica, which is the most common mineral group if you think about silicates. So silica also influences within the rock color, melting temperature, and viscosity. And viscosity is just resistance to flow. So if you think about water has a low viscosity, so it runs very easily, whereas something like syrup or honey is much thicker, so we would say it's more viscous. It resists flowing more. So there's three basic types of magma. You have basaltic, andesitic, and rhyolitic. And we'll come back to this and we'll talk more about its significance as we go through the chapter. Minerals within the magma also have different melting points. So remember, the melting point changes based on temperature, pressure, water content, but you also have this change depending on the specific minerals inside of these rocks or within the magma. So for example, rocks like basalt are going to melt at higher temperatures, whereas rocks like granite that have different minerals in it are going to melt at a lower temperature. So what happens is if you get a rock that has a combination of minerals, you can get an instance where, say at 800 degrees Celsius, part of the rock melts, whereas the other part still remains solid, because some minerals melt at a higher temperature, maybe like 900 degrees or 1000 degrees. And what this does is this leads to a change in the rock's composition, which then gives us ultimately the different types of igneous rocks. So then we have this term called fractional crystallization, which says the first minerals to crystallize are the last to melt. So essentially, once these crystals form, they no longer react within the magma. So what happens is these crystals will settle down, they'll kind of force that magma up, and then as it cools, it'll lead to those different types of rocks. So this process of crystal development ultimately leaves behind the silica, the potassium, and magnesium, it should say, not magma, leading to potassium feldspar, which is one of the minerals you looked at, the pink one, and is very common in Earth's crust. And then you'll also get a lot of quartz veins from this process. Jumping to our last term, we have Bowen's reaction series, which states that this magma cools and crystallizes in a predictable pattern. So this diagram below shows how it cools and crystallizes. So remember that as magma cools, you're going to get these mineral crystals to form. So what happens is these crystals can then react with the magma to form new crystals, and ultimately how long it takes for that magma to go from a hot and molten material to igneous rock is going to determine essentially what it forms as it happens. So again, just like the longer you give a crystal to develop, the bigger the crystal is going to be. In this case, the longer you give that crystal to develop, the different reactions it's going to go through will change ultimately the igneous rock that it forms. So I know there's a lot going on here. A lot of those terms are definitely tricky, so take a look at those again if you need to, but ultimately you should now know how an igneous rock forms. You should be able to list the 3 types of magma. You should be able to describe what silica is and then what silica influences. And then also, you should be able to explain partial melting, fractional crystallization, and Bowen's reaction series. And those are 3 definitely tricky terms, so take another look at that if you have to. Otherwise, that concludes Chapter 5.1.